All right, we're going to do lesson 3.8, which is about the point slope and linear modeling. This begins on page 393 in your textbook. We're going to start with the classwork here in the middle of page 393. The scenario that we're given here is that, congratulations, your boss thinks highly enough of your organizational skills to put you in charge of a gala to benefit a local no-kill shelter. You find an appropriate banquet hall and are told that hosting 150 people will cost $6,500. If you up the number of guests to 200, then the bill jumps to $8,500. So we're going to play with those numbers and come up with some things here as we go through these problems that'll help us model this and make some predictions. But first, let's ask ourselves, if we make the reasonable assumption that the relationship between the number of people and the cost of the banquet hall is linear, do we have enough information to model this cost? And by model, we mean an equation that provides the cost for a certain number of people. So normally we would discuss that, but the answer is yes. We will find this out in a little bit, that it is yes, and we will be able to model this for this scenario and other scenarios. Which quantity should be the independent variable and which quantity should be the dependent variable? We've been talking about this for a long time when since we've been talking about linear models and equations of lines and modeling scenarios and independent and dependent variables. So what you should deduce is that the number of attendees is what affects the cost. So that means that the number of people is the independent variable and cost is dependent. So let's jot that down. So cost is dependent and number of people is independent. And again, that means that the cost, the total cost of the banquet depends on how many people we're planning on hosting. So using that information, can we write 2 points based on that? So we're thinking of X as our corresponding with our independent variable, which again is the number of people, and cost working with the Y. So we're going to do, I'll write that down just so you can see that. Number of people is X, is going to be represented by X, and the cost is going to be represented by Y. And so we're going to write 2 points, and then we're going to use the points to find the slope of the line using our slope formula. So we've got, from our initial scenario, if we have 150 people, that means it costs $6,500. And then we also read that if we upped it to 200 people, it would cost $8,500, $8,500. So using those 2 points, X1 and Y1 and X2 and Y2, we can use our slope formula to do Y2, which we're going to be is 8,500 minus Y1, which is 6,500, all over X2, which is the corresponding X value, 200, minus X1, which was the 150 people. And when we simplify that, we get 2,000 in our numerator over 50. The difference between those two numbers is 50. So the difference in the Y's and the difference over the difference in the X's, and that reduces to 40. So our slope is 40. What does that tell us? We always want to think about what does that mean and how can we apply that? So what does our slope tell us about the cost? So what that means is that this is 40 over 1, and the change in the dependent variable is money, and then the change in the number of people is 1 person. So what that means is for each additional person costs $40 additional. So I'm going to write that down. Each additional guest increases, and since it's positive, I'm going to use the word increases cost by $40. So we're thinking of that in terms of money and people. Okay, now the bigger question. Can we find the equation of the line? So we already know the slope. If we knew the y-intercept, we'd be okay. But we don't know the y-intercept, so we're going to have to think a little bit more about that. So using x for our independent variable and y for our dependent variable, which we've been doing, we can write a generic equation for cost using the slope-intercept form of the line, which we already know. And then we can substitute in the slope that we found into the information for one of those points. And this will give us an equation that we can solve for y. So we're really going to think about this as, what he means by all those words is that we're going to think about this as y equals mx plus b. That's our slope-intercept form right there. And we're going to substitute in the slope that we found for the m in the formula, and that's going to be 40. And so now we have y equals 40x plus b, but we are still trying to solve for b. That's our goal because we don't know the y-intercept, but we do know an x and a y. So I'm going to use the first point that we used, our x1 and our y2 from the previous couple questions, and I'm going to put in 6,500 for my y, and that was associated with 150 people coming to the gala. And I'm still going to leave b as a variable. And so then we can solve it. If you have one variable and one equation, you can solve it. So I'm going to multiply 40 times 150, which is 6,000. And I'm going to subtract 6,000 from both sides to get that b isolated. And that leaves me with 500 is my b. Now that's going to help me find the y-intercept. And we're not writing the equation yet, so that was all that was asked in number 5, but now we're asked, what does it mean? What does that y-intercept mean? Is that, well, in this case, it means that if we have no guess, if we have 0, so 0 guess, it's still going to cost us $500. So that might be like a booking fee, right? So no guess still costs $500. And now I'll write it down maybe as a fee. Right, that might be a fee. Okay, so we know that the slope is 40 and we know that the y-intercept is 500. So we could plug those in for m and b in our y equals mx plus b form, which is our slope-intercept form, and that will give us the general linear model for this scenario of guess and total cost of our event. So by plugging 500 in for b, which is what we solved for in question 5, and 40 for the slope, which we solved for earlier, we have y equals 40x plus b. And then here's a reminder of exactly how to do what we just did. So first, if you find the slope using the slope formula, then you'll have the slope, and then you can plug the slope into the y equals mx plus b form, leaving the b as the variable and plugging in a coordinate, the coordinate that corresponds with x and the coordinate that corresponds with y, or the values that correspond with them in a coordinate, and then solve for b, just like we did right here above. So rewind and watch that. And then we plugged each of the slope and the b term into the general formula, leaving the x and the y as they were. So that's a good reminder there at the bottom of the page for how to do what we just did. Now we're going to take that and we're going to graph it so that we can apply some more things to figure out more about this scenario. So we know that the y-intercept is 500. It tells me to use the two original points that were given. So we have 150, 6,500, which is right about there. And when we had 200 guests, it was an $8,500 cost. And so that looks something like this. There we go. That's not too bad. So that's what our line looks like. And then we're saying that if our line doesn't go through that, then we probably graphed the wrong line. Okay, so now we're going to generalize. That's what we like to do. So we know that the slope of the line connecting any 2 points on this graph that we just drew on this red line is 40. So from here to here is 40, and from here to here is 40, or from any 2 points that we pick anywhere on that line, the slope is going to be 40. If we call one point on the graph x and one point on the graph y, then we can find the slope between that generic point and the point 150, 6500. So what that means is a little tricky to understand what they're doing. We're really using that slope formula, m equals the change in the y values over the change in the x values. But instead of writing m, I'm going to write 40. So we already know that. So again, this is a generalization, and we're going to take the difference in the y's, which one of them is actually y, and then the other one is that 6500 that they give us. So we're going to find the difference between those, which we really can't find because the y is a variable, but we're generalizing, over the change in the x's, which again, we're going to use the x, and we're going to subtract the corresponding x value, which is 150. So this is all we're asking. So finding the slope of the generic point looks like this. Now we're going to use that for question 11 to multiply both sides to clear our fractions. So what I'm really going to do, let me see if I can just do this on the previous one here. So what I'm going to do is that we're clearing the fractions, which means I'm going to take that denominator and multiply it on both sides to figure out what they want me to do in question 11. So x minus 150 on both sides. Oops, I already wrote the parenthesis over there. There you go, double parenthesis. So that's going to clear the fractions on the right side, and it's going to leave us with this general looking formula here, where we have 40 times x minus 150 is equal to y minus 6500. Now that is what we call the point slope form of the line. It looks a little different here when we scroll down to the bottom of the page, but that's exactly what we just did. So it's true for everything on the line. So in general, we can say if we have the slope and we have one point, so that's kind of what we started out with. We had the slope, well, we had 2 points and we found the slope, but if we have the slope and we have 1 point, we can use this formula, point slope. We can fill in the slope, and then we can put in the x value into that x sub 0 spot here, and then we can put the y value into the y sub 0 spot. For question 11, I have the sides kind of switched. I have the y's on the right and the x's with the distribution on the left, but this is our general formula down here. And so they even wrote it out. And as an example, if we have 1.2, 7, and the slope is -3, we would write it out like this. We'd put in the -3 where the slope would go in that general formula, and we'd put parentheses around the quantity x minus 2, because that was our x value, and the corresponding y value would go on the left side with y minus 7. I think we have one more question before we're finished with this topic. So we're going to solve what we had up here. So we had this general formula in question 11. We're going to solve that for y, and then we're going to play with that more in the group activity. So let me see if I can rewrite that. 40 times x minus 150 is equal to y minus 6500. And we're going to solve that by distributing the 40 through. And so that'll give us 40x minus 6,000 is equal to y minus 6,500. Let me actually, is that right? 4 times, yeah, that's right. And then we're going to solve for y. It's telling us to solve for y. So we want to add the 6,500 to both sides. And when we do that, we'll get 40x plus 500 equals y. That should look pretty familiar to you because that's actually what we figured out for question 7 when we wrote it in the slope-intercept form. So Now you can practice